All right, so for today, we're going to be discussing domain and range of two types of functions, and actually domain of two functions, range of just one type. So we're going to start off with the one where we have to do both domain and range, okay? So we're going to discuss the domain and range of square roots. That's going to be one of them, and then the other one's going to be of rational functions. But let's talk about square roots first, okay? So square roots. Now I know that you know how to take square roots of numbers, but when it comes to functions, there's a certain things that you can't have occur inside of square roots. So, given y equal to the square root of x. Now I'm just doing the most basic function because I just want to define a couple of things. Okay, here are a couple of things that you should not have. Okay. The square root on the inside, what they call the radicand, so the x value, it can't be negative. So in other words, the radicand can't be negative. Okay, in other words, x has to be greater than or equal to 0. Okay, remember the radicand is the stuff inside of the square root. It doesn't just have to be x. It could be an x minus 3. It can be a 2x. It can be a 4x minus 8. It can be whatever it wants to be. But whatever is inside has to be greater than or equal to 0. That's a formula that you're going to kind of work with to try to figure out your domain. Okay, so this is going to be for domain. I'm going to put this right here. This is going to be for domain. Now, another thing that you're supposed to know about square roots, in this case, the square root of x. I'm just going to draw a really quick sketch of one, okay? Nothing too perfect here. They look like this. That's what y equal to the square root of x looks like. Now, if you had something like this, and this is all just kind of review, so I'm hoping some of this is coming back to you guys because you've done this before. But for some examples, if I gave you y equal to the square root of x and then a minus 2 on the outside. Not inside the square root, but on the outside. What does that minus 2 do to the graph? Anybody remember? It's either going to move it left, right, up, or down. And it's on the outside, not the inside of the function. I'm trying to give you a couple clues before. Anybody remember? So a minus 2 on the outside brings it down twice. Okay? So this is going to move down twice. Okay? What if I put something like this? What does that do? Up 3, right? Yeah, it's going to move up 3 times. Okay, here's a tricky one. What if I do that? One to the left, it's actually one to the right. Remember how inside of the functions it always does the opposite? On the outside it does exactly what it's supposed to do, but on the inside it does the opposite. So a minus means move right once. So this would be which direction? Left twice, right? Remember, we did this in this class. You've done it before in Algebra 1, I think. talking about domain and range. So this is stuff that you guys have seen before. It's just having to remember it. Okay, having to remember. So why is it important to know this? Well, because they're going to ask us for range. So like right now, domain is your x values. How far left, how far right does it go? Okay. Range is how low to how high does it go. So if I were to give you a picture that looked like this, so let me put another little example here, because we're just kind of going over a couple examples. That way you can see what these things look like. But let's say I give you something that has a picture like this. And I'll be kind of exact on these things. If I ask you to find the domain and the range of this picture, the domain is going to ask you how far to the left, how far to the right does it go. So how far to the left does that green graph go? I'm going to zoom in a little bit here. How far left does it go? Well, it passes 1. Doesn't it go further to the left past 1? Does it touch the y-axis? Like, isn't it right here? Right? All the way to this point right there? So I would say that its domain starts at 0. Remember, the bracket means it includes it. Okay? A parenthesis means it's not included. How far to the right does it go? Notice there's an arrowhead at the end of that line. How far to the right is it going to keep going? Well, is it going to stop? No. So it's going to go to positive infinity. And if you guys remember, you'd never put a bracket on infinity. You got to put a parenthesis. All right, the range. How low does it go? In other words, the y value. What is the lowest y value? -1. How high is it going to go? And I know this is kind of tricky, but you got to remember this graph is not only traveling right, but it's traveling up forever. Okay, that's what that arrowhead is basically saying. It's going in this direction forever. So is it ever going to stop rising up? No, it's going to rise up slowly, but it's going to keep going forever. Okay, so just so you know, the way you're going to find range on these graphs is based on your outside number. So one more thing on this and then we'll move on. So given, I'm going to give you an example here. Y equal to 2 square root of x plus 4 minus 3. I'm going to give you basically like the key how to figure out domain and range given an equation. Like you may not even know what this graph looks like. Okay? But here's how you find the domain and the range. So for domain, you're going to get your radicand, which is x plus 4. And remember, the restriction on it is that it has to be greater than or equal to 0. Now just solve. I got to subtract 4 on both sides, right? So if I subtract 4, this says x has to be greater than or equal to -4. That's my domain right there. You can either write it like that, or you can write it like this. Because that says the same thing. It starts at -4 and it goes up forever. That's what x greater than or equal to -4 means. This is your domain. That's not too hard to do, right? Just look at the inside of the radical and make it greater than or equal to 0. Okay? So whatever's inside the radical, put it greater than or equal to 0, solve for it. That's going to give you your domain. Okay? And I just showed you two different ways that you can write it. The top one is correct, but I don't know which way they're going to want you to do it on the CASP. So if they want you to do it in set notation, the bottom one, then you have to say, okay, well, it has to be bigger than or equal to -4. That means it can be any number bigger than that or equal to -4. So I'm going to start with the bracket, -4 to positive infinity. Now, your range, you're going to find your range by looking at your outside number. Okay, the outside number. So I'm going to kind of highlight this thing here. Let me do it this way. That way you can see the connection between these two things here. So your domain is based on this. Okay. So your range is based on your outside number. That number tells you the lowest it can go. After that, it can go higher than that. So I'm just going to write y is greater than or equal to -3. Okay, or if you want to write it like this, -3 to positive infinity. Okay, and that's how you find your range. Just look at that very last number. Okay. So let me give you guys a little problem to work on your own. Okay. So this is one of the problems from your homework. I'm not saying this is number one, but it is a problem from your homework. Y is equal to, and I'm giving you this one because the way they wrote it is kind of weird. So I'm going to advise you to rewrite it. So this is what it looks like. I think it's the only one that's written this way. I'm going to rewrite it for you guys so that it looks kind of normal. There you go. I would say use this one. So do me a favor, find the domain and range. Remember, for domain, you're going to get your radicand. That means the stuff inside the square root. You're going to make it greater than or equal to 0 because all the numbers inside the square roots have to be either 0 or bigger. They can't be negative. And then for your range, just use your outer number, and you're going to make sure that it's greater than or equal to that outer number. And right now we'll do it, and then once we get that done, we'll move on to the rational functions. Just give you another 30 seconds. Finding the domain and the range. Right, can anybody give me the domain? Anybody know it? What is it? X. Greater than or equal to -3 is correct. Okay. X greater than or equal to -3. How do we do it? Get your radicand, x plus 3. It has to be positive or 0. So meaning it has to be greater than or equal to 0. Subtract 3 on both sides. So x is greater than or equal to -3. Now, if you want to write it in set notation, -3 to positive infinity. Again, I'm not sure which way they prefer. Some questions they might want you to write it with an inequality. Some questions they might say, we will need you to write it in set notation, so or interval notation, shall I say. Now, the range is easier. Look at the number on the very back, -2. Right? That's, you're just going to basically say y has to be greater than or equal to -2. Or -2 to positive infinity. Okay? And that's going to be your range. Okay, are we okay with these? Because you got 4 questions like this. Now you got 3 because I did 1. But they're all just like this. They're going to give you the equation. They're going to say find the domain, find the range. It's pretty easy. They didn't make it like super tricky or anything. This is probably the hardest question. Okay. Now, if there is no -2, let's say there's a problem and this isn't there, then where does your range start? At 0, right? Because it's not there. So you would say y greater than or equal to 0. Okay? So just know that they don't have to include the number at the end, which in these 4 problems they always did. But if they don't have one, it's going to be at 0. So, all right. So that's square roots. Okay? Then we got rational functions. So rational functions. Now the nice thing about rational functions, at least from what they're going to have you guys do, is all that matters is the domain for these. Okay, so we're going to put right here domain only. Okay, now with rational functions, I'm going to put given y equal to 1 over x. Now, it doesn't have to be just a 1 on top. There can be other stuff, and we'll talk about that as we do some examples here. But that's considered a reciprocal function, but it's still a rational because rational means fraction. So it's still a fraction. Given something like this, the domain is found. I'm going to put right here, find the domain by setting the denominator equal to 0. Okay? So find the domain by setting the denominator equal to 0 and solve. Okay? Whatever you get, that's the numbers you can't use. Okay? So I'm going to put the solution is or are the numbers, numbers that cannot be used. I know this sounds complicated, but it really isn't terrible. So to find the domain on a function that's a fraction, you're going to look at the denominator, you're going to set it equal to 0. Okay? Whatever, once you set it equal to 0, you're going to solve it. Whatever numbers you get, those are the numbers you cannot use. Okay? You can use everything else, just not the numbers you solved. So if you got like x equals to 3, then you're going to say it's all real numbers except for x equal to 3. Right? If you got x equal to 2, you're going to say it's all real numbers except for x equal to 2. Right? So whatever you solve for, those are the things you cannot use. So you're just going to set your denominator equal to that, to 0 and solve. So here we go. These are a couple of examples from your homework, okay? This is going to be number 2 here. So they're going to want you to find the domain. So we're going to do 2 examples, then I'll give you guys this work. The stuff that we're doing is not that it's super difficult. It just takes a little bit of time to explain to you guys where to look. Okay? But once you know where to look, it's pretty easy. So here's one of the problems. This is from your homework. F of x is equal to negative 1 over x plus 7 minus 3. Now, I know the problem looks really weird and complicated, but remember what I told you. Where do I have to focus when there's these fractional problems? What's the important part? If you look at the definition, the domain, but we're going to look at the denominator, right? Look at the denominator. So what's my denominator? X plus 7. So all I'm going to do is get x plus 7. Set it equal to 0, because that's what I told you you're supposed to do. Solve So x is -7. That's not my domain. That's what my domain cannot be. So my domain is all real numbers where x cannot equal to -7. Remember, when you solve, it tells you what number you cannot use. So they're saying don't use -7 because -7 is going to make it a 0, and 1 divided by 0 is undefined. That's not good. So don't use -7, but you can use any other number. Just don't use -7. Okay. Now this is pretty easy. Just look at your denominator and everything's good. The problem is that sometimes they don't look this simple. So let me show you one that does not look that simple. So here's the one that probably looks like the most complicated problem. Okay, where did I tell you to focus on? The denominator, right? So don't worry about the top part and the bottom part and all this stuff. But look at the denominator, set it equal to 0. So let's do that. 2x squared plus 2x minus 12 equal to 0. And then I'm going to start trying to factor this. This is a trinomial, but before I start doing an x method, I'm going to get rid of all the 2's, because notice they all have a 2 in common. So 2x squared plus x minus 6 equals 0. Now, I can factor this, I think. We'll see right now. I think I can. If I can't, then I'm going to have to use a quadratic formula. That's the only other way you can solve these things. But let's try it. My a term is, let me use a different color here. My a term is a 1, my b term is a 1, my c term is a -6. So a is 1, b is 1, c is -6. So a times c is -6, b is 1. Two numbers that multiply to -6 that add up to a +1 would be a +3 and a -2. Right? +3 times -2 is -6. 3 minus 2 is 1. So that makes perfect sense right there. So my factor is x plus 3, x minus 2, and that's still equal to 0. We know what we can do with this, right? Those little factors that are multiplying and they're both equal to 0, we can make little equations out of them, right? So there are 3 parts. So just so you know, one of them is 2 equal to 0, which is totally not true. So I'm not even going to bother with that. X plus 3 equal to 0, and x minus 2 equal to 0. What are my two answers here? X equal to what? And the other one? +2. Remember, those are the numbers I cannot use. Okay? So for my domain, I'm going to write all real numbers where x cannot equal to, I'm going to use set notation, -3 and 2. So I can use any other number I want. It doesn't matter. As long as it's not -3 and as long as it's not 2. Everything else is fine. So my domain will be just that. This is what you guys are working on in your homework.